In this video, you're going to learn about group data. When we say group data, these are tabular problems with range and given frequencies. This differs from your ungrouped data, whereas for your grouped data, you have to encounter individual elements in range. Okay? Your individual elements are groups in range, whereas for ungrouped data, they are not groups in range. For standard deviation, sample variance, population deviation, population variance, okay, we have the following variables. For your mean, it is represented as x bar. For your frequency, f. For your individual element as x. For your midpoint as m. For the following formulas, we have your mean, x bar is equal to summation of your frequency multiplied with the midpoint all over the summation of the frequency. To determine now your midpoints, m is equal to the lowest value in range plus highest value in range all over 2. For your standard deviation, it is represented as your s would be equal to the square root of the summation of the following quantities as your frequency multiplied with the quantity of midpoint minus your bar quantity squared all over your summation of frequency minus 1. For your sample variance, you're just going to square standard deviation as s squared. And for population deviation, sigma. Sigma now is equal to the square root of summation of the following parameters: frequency multiplied with your midpoint minus your bar squared all over the frequency or summation of frequency. And for your population variance, you're just going to square population deviation. And for your z-score now, z is equal to frequency multiplied with midpoint minus your x bar all over your sigma. Now let's proceed. An example, a data of students' grades is given below in range with the number of students incurred. We have the leftmost column as your grade range, 50 to 59 with a frequency of 3, whereas for 60 to 69, a frequency of 5, 70 to 79 range, a frequency of 9, 80 to 89, 12, and 90 to 100 of a frequency 8. We are going to calculate the standard deviation, sample variance, population deviation, and population variance in z-squareds or z-scores. For the grade range, okay, you're going to position the data for the range at the leftmost part of the column and frequency or following it with frequency. Okay. The next step is you're going to sum all the values of the frequency per range. So 3 plus 5 plus 9 plus 12 plus 8 gives us 37. And for the midpoint, we're going to solve your midpoints per range or per row. Okay? For the midpoints here, we have the lowest range at 50 and the highest range 59. To get now the midpoints, you're going to have both. So 50 plus 59 all over 2 gives us 54.5. For the 60 to 69 range, 60 plus 69 all over 2 gives us 64.5. And for 70 to 79 range, 70 plus 79 all over 2 gives us 74.5. For the 80 to 89 range gives us the half of 80 plus 89, which is 84.5. And the half of 90 plus 100 is 95. For the fourth column, you're going to solve for frequency multiplied with the corresponding midpoints. Okay? For this problem, for the range 50 to 59, your frequency is 3 multiplied with the solved midpoints. 54.5 gives us 163.5. A value of 322.5, 670.5, 1,014, and 760 for the corresponding ranges of 60 to 69, 72, 79, 80 to 89, 90 to 100, respectively. After getting the corresponding frequency multiplied with midpoints, okay, with the corresponding range, you're going to sum all the values at your fourth column. Okay, 163.5, 322.5, 670.5, 1014, 760. If you're going to sum up all the values, gives us 2930.5. This next step you're going to do is to determine the mean. Okay, your mean now x bar is equal to the summation of, okay, quantity at your fourth column all over the total frequency. Okay, so 2930.5 all over 37 gives us 79.20 or 79.2. For your fifth column, n minus x bar gives us, okay, 54.5 minus 79.20 or negative 24.7. For the m here, 64.5 minus 79.2 gives us negative 14.7. 74.5 minus 79.2 gives us negative 4.7. Okay. 5.3, 15.8 values for 80 to 89 and 90 to 100 ranges respectively. For the sixth column, okay, whatever values you get at the fifth column, you're going to square it individually. If we're going to square it, negative 24.7 quantity squared gives us 610.09. Negative 14.7 quantity squared gives us 216.09, and the square of negative 4.7 is 22.09. The square of 5.3 is 28.09, and the square of 15.8 is 249.64. Afterwards, you're going to sum all your data or values here, which gives us 5,443.73. Now, the solution proceeds, okay, with the standard deviation, sample variance, population deviation, and population variance. To determine your standard deviation, S now would be equal to the square root of the following quantity, or 5,443.73 all over 37 minus 1. If we further simplify the following quantities, gives us 12.3. For sample variance, you're just going to square 12.3, which gives us 151.29. For the population deviation, sigma, okay, your sigma now is equal to the square root of 500 or 5,443.73 all over 37, which is equal to 12.13. To determine now the population variance, you're going to square the value 12.13, okay, which is equal to 147.14. The last thing to solve is the z-score of the corresponding range. To determine this z-score, okay, we have the quantity frequency multiplied with the quantity of midpoint minus mean all over your sigma. Since our sigma, our population deviation is equal to 12.30, okay, that would be on the denominator of negative 74.1 for the range of 50 to 59. For the range of 60 to 69, how are we going to solve it? Okay, so we have to multiply your negative 14.7 with the frequency of 37, which gives us a value all over your 12.13. Okay, further simplifying it gives us negative 6.06, negative 3.48 for 70 to 79 range, and for the range of 80 to 89 gives us 5.24 value for its corresponding z-score, and for the last one, 90 to 100, a corresponding value of z-score of 10.42. Again, if we're going to solve for z-score, we have this formula as z is equal to your frequency multiplied with the corresponding row of m minus your mean all over your sigma. That ends my presentation. For any questions, you may message me on my messenger account. And do not forget to like this video and subscribe my YouTube channel.